Hi, my name is Michael Gerkman, and today I'm going to talk about the different types of chemical reactions. So the first type of chemical reactions are the combination reactions, where two atoms or molecules combine together to make one single molecule. So in this case, the blue atom and the green atom combine together to make this blue-green molecule. The opposite of a combination reaction is a decomposition reaction, where one molecule decomposes into two molecules or atoms. So in this case, the green-blue molecule decomposes into a blue atom and a green atom. The next type of reaction is the single displacement reaction, where in this case, we have our blue-green molecule again reacts with a yellow atom. And now the yellow atom replaces or displaces the green atom in the blue-green molecule, generating a new blue-yellow molecule and a green atom. The next type is a double displacement reaction. In this reaction, we have our blue-green molecule again with a yellow-red molecule. And then after the reactions occurred, you can see that the green molecule and the yellow molecule have actually switched places. So now we have a new blue-yellow molecule and a new green-red molecule. The next type of reaction is a redox reaction. A redox reaction occurs when electrons are transferred between atoms or molecules. In these reactions, one species is oxidized and one species is reduced. Oxidation is the loss of electrons, while reduction is the gain of electrons. So now let's look at a simple redox reaction. So in this redox reaction, zinc solid reacts with copper sulfate in the aqueous phase to generate aqueous zinc sulfate and solid copper as a precipitate. Now this looks like the single displacement reaction we talked earlier. Now let's also look at its ionic equation. So you can see here in red, zinc goes from a neutral species to a 2+ species. So zinc during the reaction has lost 2 electrons and is oxidized. And now if we look at the copper molecule, it starts off as copper 2+ and goes to copper 0. So it has gained 2 electrons and is reduced. The next type of reaction is combustion reactions. A combustion reaction occurs when oxygen gas reacts with a substance releasing light and heat. This is commonly known as burning. Now, in this equation below, we're looking at the burning of sugar. So the sugar molecule can be written as C6H12O6, can react with 6 molecules of oxygen, and then this generates 6 molecules of carbon dioxide and 6 molecules of water and releases some heat. So now let's talk about today's demonstration. So our demonstration is going to start off with the melting of potassium chlorate into liquid potassium chlorate. Now liquid potassium chlorate decomposes into 2 molecules of potassium chloride and 3 molecules of oxygen gas. Now we're going to use this oxygen gas to feed our combustion reaction. Now, in this combustion reaction, we're going to use sugar to do the same reaction that I talked about previously. So to put this reaction in simple terms, we're going to use decomposed potassium chlorate into salt and oxygen and use that oxygen to help burn sugar into carbon dioxide, water, and generate a lot of heat. Now, let's move to our video of the following demonstration.
Hi, my name is Michael Gerkman, and I'm a 5th-year graduate student at Brandeis University, and today we're going to talk about a very fun type of reaction, the combustion reaction. And the combustion reaction normally involves some carbon-containing molecule that would expose to heat and oxygen burns. So that's when you burn wood in your fireplace at home. That's a combustion reaction. So we're going to do something very similar to that on a small scale. So in our reaction, we're going to use potassium chlorate as a source of oxygen. So when potassium chlorate melts to a liquid, it spontaneously decomposes into potassium chloride and oxygen. And we're going to use that oxygen generated to do our combustion reaction. So let's first talk about my setup here, because for this type of experiment, you should not do it at home, and it can be dangerous. So this is why we're taking these precautions you can see here. So the first thing that you see is the blast shield here. This is in case there's any type of explosion. We can be protected from that. The next is this test tube holder and ring stand to hold our reaction. And then a pair of tongs to safely drop our gummy bear into the test tube. So the potassium chloride starts off as this nice white powder here, and we're going to pour that into our test tube. All right, and the gummy bears we're using, just any old gummy bears you can find inside a store. And now we're going to use this propane torch to melt the potassium chlorate. And what you'll see is as it melts, it'll start to bubble. And that bubbling is the release of oxygen. So it's taking a little while to heat this up. Great, so now we have our liquid potassium chloride, and now we're going to drop in our gummy bear and see what happens. And so now you can see this pink-purple color is actually the potassium chloride burning, and then the red little flames on the inside is the combustion reaction. And that is our small experiment of a combustion reaction. So again, just like to reiterate, this is not something you should do at home and only be done by a trained professional.